This is SpaceTime Series 25, Episode 61, for broadcast on the 5th of June 2022. Coming up on SpaceTime, a successful test for Gilmour's new Phoenix rocket engine, why the ice giants Uranus and Neptune are coloured differently, and a mysterious new type of magnetic wave discovered on the surface of Earth's core. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Gilmour Space Technologies says everything's still on track to undertake an orbital test flight of its Eris rocket from Queensland's Bowen spaceport before the end of this year. The confirmation follows a successful full mission duration test firing of its new Phoenix liquid-fueled rocket engine. The 3D printed Phoenix engine will be used to power the third stage of the company's Eris rocket. The engine uses regenerative cooling. That's a configuration in which the cryogenic liquids are passed through tubes, channels, or a jacket around the combustion nozzle in order to cool the engine. The 192nd Phoenix burn followed a series of earlier successful tests with a series hybrid rocket engine, which will power the Eris first and second stages. The most recent 75-second series test firing achieved 110 kilonewtons, that's 25,000 pounds of thrust. The company's CEO, Adam Gilmour, says the third stage Phoenix engine will provide the extra performance needed to deliver substantially more payload to orbit. He says liquid-fueled rocket engines are used by most rocket companies around the world and are notoriously complex and expensive to develop. With this latest test, Gilmour Space has demonstrated sovereign capability with not one, but two very different rocket engine designs. Gilmour says the team's done exceptionally well to be able to design, build and test this new engine in just over a year, while at the same time also scaling up the main rocket engine and, of course, building out the rest of the launch vehicle and pushing to develop a new orbital launch facility in Australia. The company recently won a contract to build and launch a new Australian defence surveillance and intelligence gathering satellite. Gilmour Space Technologies Program Manager David Doyle says the Eris test marks an important milestone in the development of a sovereign space program.
As you mentioned, the third stage engine, which is the liquid oxygen and kerosene or liquid bipropellant rocket engine, as we call it in the business. We just did a full duration or mission duty cycle test of that upper stage, that third stage engine, which was incredibly successful. So as mentioned, it ran for mission duration and everything was nominal. So very, very excited, very happy, and it's a great achievement specifically by our propulsion team to have reached this point in such a short amount of time.
Now, it's not the only engine you've developed. There's the hybrid rocket engine as well. That'll be powering the first and second stages?
Yeah, exactly. So our Eris launch vehicle, which is the first of our launch vehicle product that we have in the company, a small lift launch vehicle, that is a three-stage rocket. As you pointed out, the first and second stage will be powered by hybrid propulsion technology, which is a liquid oxidizer and a solid fuel as propellants. And then the third stage will have a single Kerolox bipropellant rocket engine, which is what we just tested.
And the reason for the different types of fuels is the third stage needs to be able to turn off and on?
That's one of the reasons. So for accurate orbital insertion for satellite payloads, it's very useful to be able to phase the orbits and separate out multiple payloads for deployment. So that is one of the requirements for that upper stage engine. But for a liquid engine over a hybrid or a solid engine, liquid is much more efficient. So to get to the extremely high velocities that we need to get to for an orbital launch vehicle, which really sets us apart from suborbital sounding rockets, that high velocity is best achieved through a very efficient upper stage engine. And so we made the switch to a liquid Kerolox engine, which does give us really high efficiencies. And that's why first and second stage can be a hybrid, because we really need that oomph to get out of the Earth's gravity well and to get out of the atmosphere to minimize drag. And so we can afford to use a slightly less efficient propulsion technology like hybrid, which is high thrust, but then also very low cost and quick to manufacture, which is why we went that pathway on the first and second stage.
Tell us about the rocket itself, the launch vehicle.
In terms of an overview, Eris is a three-stage rocket, as we mentioned, roughly 23 metres tall, so pretty tall, and 2 metres in diameter for the first stage, tapering to 1.5 metres in diameter across the second and third stages as well. In terms of development, pretty much everything has been designed, developed, and a lot of it is being manufactured by Gilmour Space Technologies in-house. We have an extraordinarily large supplier network here in Australia with a lot of companies who've never worked in the space industry before and really want to tool up and get involved. And so we've worked very closely with them over a number of years to be able to get to this point and bring them on the journey. We also have a few international suppliers that we work with, mainly in Europe and the UK as well. We bring all those together in the work we do in-house to be able to design and manufacture the Eris vehicle. In terms of progress, where we're at the moment with these recent tests, we're beginning to close out the final subsystems, so sections of the different propulsion systems, structures, airframes, mechanisms, avionics, software, doing all of our final tests in the lead up to final assembly and integration, and what we will call a stage or vehicle level testing to occur later on this year. So we're across those final tests, nearing the point that we'll transition to testing out at our launch site in northern Queensland towards the end of this year.
Now, the original plan was to launch your first orbital payloads this year. Is that still likely to happen?
Look, I'd say we're still on track to be able to achieve that. There's obviously a number of factors that go into it. Extraordinarily complex and difficult, both technically and in other areas in terms of regulations. There's a lot of new things that the industry, government, state and federal governments have to sort of work through for the first time, as well as us on the technical side. And there's a lot of factors at play here that could potentially influence that and push that into 2023. At this point, we're still on track to be able to achieve our aim and vision of getting away an orbital attempt this year. But like I said, there's a lot of different variables here in this equation. So let's cross our fingers and hopefully Australia can get to orbit this year.
What sort of payloads are you expecting to launch?
We have our first design variant of the Eris launch vehicle, Block 1 as we call it. We've also got a second major design variant in the works at the moment, Block 2. The Block 1 variant, which we'll be launching this year and next year as well, carries in the order of 100 to 150 kilos to low Earth orbit. The Block 2 variant, which will be online in the next few years, will be able to take up to 1,000 kilos to low Earth orbit, so quite a substantial upgrade in terms of the capabilities. But we're still targeting that smaller sub 1,000 kilo class satellite, which is where we see the majority of the market demands early in this decade, certainly. And we're seeing a lot of interest domestically and internationally as well with satellite customers.
And Bowen's still the location of the preferred launch site at this stage?
It is. Yeah, no, things have been progressing extremely well for us up there. So I think the last time we touched base and spoke, we were early stages and looking at mainly regulatory approvals, and we hadn't progressed with civil construction. So at this point in time, we started the civil construction process out on the launch site, and that's been progressing very, very well, working with a range of local companies up and in the area to support us in that activity. And we are definitely on track to be able to have an operational launch site this year, which is really exciting, both for us, but also for the region, who have been really, really supportive and really excited to see this type of industry come to their locale. But no, things are progressing really well and very happy with that. But again, I'll always caveat with there's a lot of variables here. There's a lot of hurdles that are yet to be navigated, and a lot of these challenges and hurdles are the first of type for not only Gilmour Space, but also for local, state and federal governments as well. So yeah, got a bit of progress to be made there. But things are moving along very well.
What does it take to build a rocket launch pad? What's involved there? There are all sorts of components, I guess, from a hard stand through to launch towers and vehicle assembly buildings and fuel storage. And what's all that involved?
Well, you've got most of the constituent components there. Maybe you know more. The launch site is really made up of, as you mentioned, a launch pad, concrete hard stand, not too dissimilar with the sort of thing you'd see at an airport or airfield. They're towers that interface with the rocket, so that the transporter erector, which moves the rocket out to the actual pad, puts it into the vertical, and then bases the rocket for umbilicals for all of the propellants, the power systems, data systems, and so on and so forth. We have fluid storage area adjacent to the launch pad, which houses all of the propellants, the gases for the rocket. Water for the water deluge system for sound suppression and other reasons. And then not too far from the pad, we have our vehicle assembly building, which is basically a big shed which houses and protects the rocket and rocket parts, as well as provides a place for people to work on the rocket out of the elements and for the payload to arrive, be processed by the payload customer and ready for integration into the top of the rocket in the horizontal. That all gets done in the vehicle assembly building before being rolled out to the tower. And then there's all of the associated control and management and oversight functions that are contained within the launch control center, which is basically comprised of theaterette-style setup for execution of operations on the launch site. So that include all of the commissioning, testing, and pre-launch operations, the launch operations, monitoring of the vehicle and ground systems post-launch as the vehicle stages and moves up towards orbit, and then all of the functions associated with delivering a safe and effective range. So that's interfacing with Air Services Australia, Queensland Police, federal agencies like the Space Agency, AMSA, and a myriad of other organisations and external stakeholders within the local and broader community and even international community that go together to deliver a successful and safe launch. With that, we also have responsibilities to maintain security in the site as part of general operations, but then also during launch activities as well. So there's all of the infrastructure associated with that go around and wrap and secure the launch control, vehicle assembly building, pad, and other functions on the site. And then you've got other things like communication, so telemetry ground receive stations that are co-located and connect into communications infrastructure and those sort of the backbone elements.
Space is hard. It's difficult.
Yeah, it is. It is extremely. There is James Gilmour, our launch site lead here and co-founder, loves to say there's a lot of wood to chop. So I think that's a perfect way to put it across the board. There is a lot of wood to chop. But I think there's some technical challenges that we've navigated and overcome, and there's still some regulatory not challenges, but just effort that needs to be undertaken by all parties. But I think there's largely known and understood effort, and it's just what we need to get through and move through. So it's certainly exciting, and we're very much getting down to, I guess, the final thrust towards to getting out to the launch site and rolling out a fully assembled integrated launch vehicle for a launch attempt later this year.
That's David Doyle, Program Manager with Gilmour Space Technologies. And this is SpaceTime. Still to come, why the ice giants Uranus and Neptune are coloured differently, and the discovery of a mysterious new type of magnetic wave running along the surface of the Earth's outer core. All that and more still to come on SpaceTime. Astronomers think they've finally worked out why the solar system's two ice giants, Uranus and Neptune, have different colours. Neptune and Uranus have much in common. They have similar masses, they're similar in size, and they're similar in atmospheric composition. Yet their appearances are notably different. At visible wavelengths, Neptune is a distinctively royal blue colour, whereas Uranus is a pale shade of cyan. Now, a report in the Journal of Geophysical Research Planets suggests there's a layer of concentrated haze which exists on both planets that's thicker on Uranus than a similar layer on Neptune, and therefore whitens Uranus's appearance more than Neptune. The findings show that this excess haze on Uranus builds up in the planet's stagnant, sluggish atmosphere, and therefore makes it appear a lighter tone compared to Neptune's deep royal blue. If there were no haze in the atmospheres of Neptune or Uranus, both would appear equally blue. The new findings are based on a model developed to describe aerosol layers in the atmospheres of the two ice giants. On Neptune and Uranus, particles produced by sunlight interact with elements in the atmosphere. These photochemical reactions are responsible for aerosol hazes. Previous studies of these planets' upper atmospheres had focused on the appearance of the atmosphere at only specific wavelengths. However, this new model looks at multiple atmospheric layers, and it matches observations of both planets across a wide range of wavelengths. The new models also include haze particles within deeper layers that had previously been thought to contain only clouds of methane or hydrogen sulfide ices. The study's lead author, Patrick Owen from Oxford University, says it's the first model to simultaneously fit observations of reflected sunlight from ultraviolet right through to near-infrared wavelengths. It's also the first to explain the difference in visible colour between Uranus and Neptune. The model consists of 3 layers of aerosol at different altitudes. The deepest layer, referred to in the paper as aerosol 1, is thick and is composed of a mixture of hydrogen sulfide ice and particles produced by the interaction of the planet's atmospheres with sunlight. At the other end, the top or aerosol 3 layer is an extended layer of haze, similar to the middle layer but far more tenuous. Now on Neptune, large methane ice particles also form above this layer. But the key layer which affects the colours is the middle layer, the aerosol 2 layer. This is the layer of haze particles which are thicker on Uranus than on Neptune. The authors suspect that on both planets, methane ice condenses onto the particles in this layer, pulling them deeper into the atmosphere in a shower of methane snow. But because Neptune has a more active turbulent atmosphere than Uranus, Owen and colleagues believe Neptune's atmosphere is more efficient at churning up methane particles into the haze layer and producing the snow. This therefore removes a lot of the haze and keeps Neptune's haze layer thinner than that on Uranus, meaning the blue colour on Neptune looks stronger. To develop this model, Owen's team analysed a set of observations of planets encompassing ultraviolet, visible and near-infrared wavelengths. That's from 0.3 to 2.5 micrometers. The observations were taken with the near-infrared integral field spectrometer on the Gemini North Telescope on the summit of Mauna Kea in Hawaii. The authors also used archival data from NASA's Infrared Telescope facility, also located in Hawaii, and from the Hubble Space Telescope. But the Gemini North data was especially important as it was able to provide spectra, measurements of how bright an object is at different wavelengths for every point in its field of view. And this provided the authors with detailed measurements of how reflective both planets' atmospheres were across both the full disk of the planet and across a range of near-infrared wavelengths. The model also helps explain the dark spots, which are occasionally visible on Neptune but are less commonly detected on Uranus. While astronomers were already aware of the presence of dark spots in the atmospheres of both planets, they didn't know which aerosol layer was causing the dark spots, or why aerosols at these layers were less reflective. And so the team's research sheds light on these questions by showing that the darkening of the deepest layer in their model would produce dark spots similar to those seen on Neptune, perhaps also on Uranus. This is SpaceTime. Still to come, a mysterious new type of magnetic wave discovered on the surface of the Earth's core. And later in the science report, a new study has found that having that morning cup of coffee could help you live longer. All that and more still to come on SpaceTime. Scientists have discovered a mysterious new type of magnetic wave that sweeps across the outermost part of Earth's outer core every 7 years. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, are based on observations obtained by the European Space Agency's SWARM satellite mission. The trio of SWARM satellites were launched in 2013 to study the planet's magnetic field. Earth's magnetic field is important. It acts as a shield protecting life on the planet from the constant bombardment of deep space cosmic rays, as well as the relentless stream of charged particles raining down in the sun's solar wind. Were it not for Earth's magnetic field, the solar wind would erode the planet's atmosphere. It would degas the Earth's water into space, and it would irradiate the surface, making life impossible. In fact, that's exactly what happened on the red planet Mars when it lost its magnetic field. Most of Earth's magnetic field is generated by the planet's molten liquid metallic outer core, swirling around the solid iron inner core, producing a geodynamo which generates electrical currents and an electromagnetic field. The swarm satellites measure the magnetic signals generated by Earth's core, as well as other signals that come from the planet's crust, its oceans, its ionosphere, and its magnetosphere. Scientists need to understand how the Earth's magnetic field is generated, why it constantly fluctuates, how it interacts with the solar wind, and why it appears to be weakening. In fact, there's an anomaly located in the South Atlantic Ocean where the polarity seems to have reversed. Scientists don't fully understand what's going on. It's likely this could be a sign that Earth's magnetic field is about to flip, that is, the poles are about to reverse polarity. On the Sun, it's every 11 years. On Earth, it takes much longer, and we're already well overdue for the next flip. Now, in the past, life seems to have survived these magnetic pole reversals without too many problems. But the difference now is we have technology. We know that when solar storms from the sun overwhelm the Earth's magnetic field, they can disrupt communications and navigation systems, black out power grids, damage or even destroy spacecraft, shorten satellite lifespans, and pose health issues not just for astronauts in orbit, but also for people traveling in high-altitude aircraft. Because of that, scientists need to know what they can about the Earth's geodynamo. This newly discovered magnetic wave appears to be sweeping across the surface of the planet's outer core, right on the core mantle boundary. It does so every 7 years, oscillating and propagating westwards at up to 1,500 kilometres a year. Geophysicists have theorised over the existence of such waves, but they've always figured they'd run over much longer timescales. Previous measurements of the magnetic field from instruments based on the Earth's surface suggested that there was some kind of wave action taking place, but scientists really needed the global coverage offered by the swarm satellites from space to reveal what's really going on. The authors combined the swarm satellite measurements with data from earlier German CHAMP and Danish Ørsted measurements, together with a computer model of the geodynamo, in order to explain what the ground-based data was throwing up. It seems Earth's rotation causes these waves to align in columns along the axis of rotation. And the motion and magnetic field changes associated with these waves are strongest near the equatorial region of the core. While the research exhibits magnetocorolus waves near a 7-year period, it doesn't explain why they'd be oscillating at different periods. The authors think the waves are likely to be triggered by disturbances deep within the Earth's liquid outer core, possibly related to buoyancy plumes. Each wave can be specified by its period and typical length scale, and the period depends on characteristics of the forces at play. For magnetocorolus waves, the period is indicative of the intensity of the magnetic field within the core. The findings suggest there could be more similar waves down there, waves which are yet to be discovered, and which would have even longer periods. But it's going to take more research and more time to confirm such a hypothesis. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that far more Australian reptiles are facing extinction than previously thought. A report in the journal PLOS Biology shows that a large proportion of reptiles have been missed in previous assessments of extinction risks, and reptiles in Australia are among those most in peril. The authors developed a new learning tool that could assess the over 4,000 species of reptiles that were previously unable to be prioritized for conservation due to a lack of data. And they found species-rich groups, such as geckos, cobras, mambas, coral snakes, and others, that are probably far more threatened than the global reptile assessment currently highlights. And these groups need to be the focus of more conservation attention. Scientists at the US Department of Energy's National Renewable Energy Laboratory have created a new record-setting solar cell capable of achieving 39.5% efficiency. The new triple junction cells are more efficient and have a simpler design than existing solar panels. They do this by using a gallium iridium phosphide top junction, gallium arsenide with quantum wells in the middle, and a bottom of lace mismatched gallium indium arsenide. Scientists say the new cells will be useful for a variety of new applications, such as low radiation environment spacecraft, still achieving around 34.2% efficiency thanks to thick quantum well superlattices. Now, by comparison, the best commonly used photovoltaic panels available today have around 22.8% efficiency. A new study has found that having a cup of coffee in the morning could help you live longer. Findings reported in the journals of the Annals of Internal Medicine show that drinking between 1.5 and 3.5 cups of coffee per day, either sweetened or unsweetened, could reduce your chances of dying over the 7-year period of follow-up observations. Now, the findings were less clear for people who are using artificial sweeteners. And accompanying editorial cautions, however, that while coffee has qualities which could make health benefits possible, there are also many variables in the study, like socioeconomic status and diet, which would make it harder to determine if it was the coffee which was the true cause of the reduced chances of death. Okay, time for what might well be the silliest story of the week. Despite a mountain of indisputable evidence proving that astrology is a swindle with no scientific backing, and the livelihood of people prognosticating it is dependent on the gullibility of stupid people, there are lots out there who keep pushing this pseudoscience in the hope of making money from the foolish. And now, as Tim Mindham from Australian Skeptics tells us, they have a new cookbook, fine-tuned to match the taste buds of your star sign.
The gourmet cookbook for astrology lovers, in which he sort of talks about different recipes that will suit different star signs. And of course, there are 12 different star signs, which they always leave out Ophiuchus, which is the 13th star sign, but you can't divide 13 evenly.
Well, even the 12 aren't divided correctly.
That's exactly right. I mean, I think it's one of them is a Libra or Scorpio, which only 7 days long, but of course it's allocated the usual 28 days or so. On the sun sign astrology, that's what this is. It's sun sign astrology, which is the cheapest version of astrology you can get. Not that the others are that much better. But it always strikes me as interesting that surely one person on the end of a star sign is closer to the next star sign than to the early part of the star sign. It's just saying that certain foods will suit certain star signs, which is absolute garbage. The astrology base is so. What I loved was that they made the amazing comment that some of the world's best-known chefs are born under the sign of Cancer. And my feeling is that's probably some of the worst. Also born under the sign of Cancer. Some of the world's best-known chefs are probably born under every other star sign you can think of. The lack of intelligence that is seen, the lack of sort of logic.
The most sensitive taste buds? I can't believe, fair enough.
I don't know. Yeah, they didn't go through all the different star signs. I'm disappointed mine was left off.
Now, I'm Sagittarius, and it's to see that I like to try exotic things because I have a sense of daring and adventure. No, I don't like exotic things. I like very basic foods.
Well, that's probably, Stuart, because you're not Sagittarius. According to the precession of the equinox, which your listeners will know fully well, means that all the star signs are shifting through the sky over a period of 25,000 years. So every 2,000 years or so, it shifts through a whole star sign.
Those Babylonians.
Those down Babylonians. It just means that not only is astrology rubbish, the star signs aren't the same size, they miss out the 13th star sign. They're also not there anyway. You're not in the star sign you think you are, and you don't like exotic dishes full of spices and that sort of stuff. It's a wonderful extension of the total silliness, but it reinforces the belief that astrology is real, unfortunately.
Why are they always renowned or famous if you've never heard of them?
Well, we're not going to say a complete loser of a psychic medium who no one's ever heard of has put out a book. I mean, if you look up Australian psychics, everyone is Australian Australia's best psychic. They might use a little variation on the words. But you go through and look at a lot of the, especially the media profile ones, they're always the best. And you can't all be.
Yeah, it says here people who are allegedly born under the star sign of Libra tend to like sweet things, rich foods, sugary textures.
Yeah, I like sweet things, but I also like gourmet foods, and I don't mind exotic dishes. I don't mind a bit of spice, and a bit of chicken on my curry is always nice.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.